Good morning, good evening, good afternoon. Willkommen, bienvenue, welcome wherever you are in the world. Welcome to this session on developing an AI agent with Semantic Kernel. This is the latest in a series of these Learn Live sessions that we've been doing, and all of them cover different aspects of developing agents. Today, we're going to look at combining Azure AI Agent Service with Semantic Kernel. My name's Graham Malcolm. I'm a Principal Content Development Manager here at Microsoft. I look after the team that produces our training materials on AI and development and the certification exams and so on that go along with that. And I'm joined today by Becky on my team. Becky, could you say hello to the nice ladies and gentlemen out there?
Hi, everyone. Good morning or good evening. I'm Becky Zahid. I work on the Microsoft Learn team under Graham, and I create a lot of learning paths and training modules that are focused on programming like C# or Semantic Kernel and Python. Yeah, that's me.
Awesome stuff. Great. So yeah, we're going to talk you through just a few principles of how to go about building agents with Semantic Kernel, what that means, why you might do that. And then who knows, we might even show you some examples of this stuff actually working and get to some code, because I know that's what everybody likes to see. But before we do that, we're just going to go through some kind of housekeeping slides. So Becky, if you would do the honors and flip us through these slides, let's just carry on from here. So I think, yeah, there we go. Taking a little while to refresh here. So this session, as I said, is based on a module on Microsoft Learn. There is a little aka.ms link there for you, which we'll also be sharing externally from this session. There's a Discord server that we'll send you to afterwards with a whole bunch of community-based chats and so on around this stuff, and you'll get links for things like these there. But I do encourage you to go and do these Learn modules for yourself, rather than just listening to us witter on about it and show you the lab. It's a good chance to actually get hands-on with it for yourself and try it out. So let's move on and talk to the next slide, which is about our moderators. It's great to have so many of you joining us today. Obviously, Becky and I will be doing our lion's share of the talking, but that doesn't mean you've just got to sit back and listen. Please engage, please ask questions. There is a chat there, and we have these fantastic moderators who are monitoring that chat and who will be willing and able to answer your questions and chat to you. And we'll hopefully get to a few of those towards the end of the session as well, and do those out loud. But please engage, please ask questions, please be curious. That would be great. All right, so I just said that. This is live and interactive. Say hi, ask questions. We are part of an organization at Microsoft that is about skilling primarily. We look after building training courses and certification exams and that type of thing. One of the things we did recently was we actually achieved a Guinness World Record for the most number of people engaged in an AI skilling event at any one time. That isn't all over with. There's a link there to aka.ms AI Skills Fest, and there's a whole bunch of different skilling activities that you can get involved in. There are hackathons, there are additional Learn modules. There's a whole wealth of resources there that can help you build your skills in AI. So we would love you to participate in that. Please join in with that, and please engage with the chat and with the community as well, and get involved. All right, so this is what we're going to be covering today, and at this point I am going to hand over to Becky, and she will take us through these slides.
Yeah, all right. Cool. So hello, everyone. Again, I'm Becky. Today, we're going to be talking about creating AI agents with the Semantic Kernel SDK. And I see there's plenty of you guys in the chat today, so that's super exciting. I am curious if you've worked with Semantic Kernel before or AI agents. Please comment. Like, I'd love to hear what you're working on, or if you've used it before. If you haven't, then I would personally like to know what you might plan on using Semantic Kernel or AI agents for in the future. But yeah, today we'll be covering what is Semantic Kernel, using Semantic Kernel plugins, why you might want to use Semantic Kernel with the Azure AI Agent Service. We'll talk about creating an Azure AI agent with Semantic Kernel, and then Graham will be showing a demo of how to use Semantic Kernel to develop your own Azure AI agent. At the end, we'll have some questions to check your knowledge, so if you want to seem like really, really cool, like please pay lots of attention. All right, so let's get started. Okay, so what is Semantic Kernel? Semantic Kernel is a lightweight SDK, and it helps you integrate large language models with your typical programming languages like Python or C#. And using Semantic Kernel can help you integrate those models quickly without needing to learn the specific coding intricacies of whichever model you want to use. And the Semantic Kernel supports a couple of tools. We have AI service connectors, memory connectors, prompt templates, functions, plugins, filters, and I'll just dive into those very briefly. So AI service connectors can connect your code to different AI services such as chat completion, text generation, text to image, much more, and they all use a common interface. Memory connectors are the same way. You can use different vector stores under a common interface. Prompt templates are very useful. They combine instructions, user input, and function outputs into a reusable format. So using prompt templates lets the model complete predefined steps with dynamic input. Plugins are containers for functions that you can write in native code like Python or C#, and you register your plugins with the kernel. The functions that you add can be invoked automatically with the AI or through your prompt templates. And finally, we have filters that can be registered with the kernel. So when a function is called or when a prompt is invoked, these filters can let you perform custom actions before and or after the result is generated. So yeah, all in all, the Semantic Kernel has a lot of really cool tools that you can use to develop your AI application. I personally really like the plugins for Semantic Kernel. They're like one of my favorite offerings of the Semantic Kernel. So plugins let you add custom functionality to your AI application. And that lets it so your code can do more than just language processing. You can create more than just a chatbot application. To add plugins to your application, you create a class that contains the functions you want to use. And to each function, you add a kernel decorator. So for example, you might want to create a function that retrieves weather data for a given city. Or maybe you have functions that connect to an external device. Or maybe you want to create plugins that like facilitate a Pokemon battle. Anyway, once you've written your functions and you've added your decorators, you can add your plugin class to the kernel. And then the functions can be invoked dynamically depending on the user's input. So it's a simple way to give your application tons of functionality. And I'm just going to look over to the chat. If anyone has any questions, please don't hesitate to ask. This is your time to shine. All right. Oh, there we go. So I'm going to talk a bit about the agent framework in Semantic Kernel. The agent framework helps you streamline the development of agents. And in regular Semantic Kernel, you might just have a chat thread between the user and the AI model. And sure, you can provide instructions to the model and you can add your plugins, but you might find it hard to create designated agents with specific purposes. The agent framework helps solve that problem. The agent framework focuses on this concept of agent conversations. And it lets you create multiple AI agents that have their own unique instructions and can collaborate in a single conversation, or AI agents can also engage in several conversations simultaneously. The agent framework supports different types of agents, including chat completion, OpenAI assistant agents, but our focus today is going to be on the Azure AI agents. And the agent framework has these core components, which you'll see pretty soon in our demo. We have the agent abstract base class, the agent thread that manages conversation state, the agent chat that manages interactions between agents and users in a conversation. We also have the agent group chat that supports multi-agent collaboration. And then there's the agent channel that manages communication between different agents. Let's see. So let's just talk about why you might want to use Semantic Kernel, because the AI or the Azure AI Agent Service does have a platform for agent development, but you might want to use the Semantic Kernel agent framework if you are already involved in Semantic Kernel. Maybe you already have a code base, maybe you're familiar with it, or maybe you want to build a solution with different types of agents. You can use Semantic Kernel to do that. It can also be very useful if you want to create a multi-agent solution with your Azure AI agent. Also, it's just really cool and really fun to use. So I'm going to talk a bit about how you can create your Azure AI agent with Semantic Kernel before we do the demonstration. Okay, so to start creating your Azure AI agent with the Semantic Kernel SDK, you first need to have an Azure AI Foundry project. And once you set up your code, you can use C#, Python, I think also Java. You can import the SDK and create an Azure AI settings object that creates your code to your Foundry project. You use the settings object to create your Azure AI agent client, and then you use the client to create your agent definition. And the definition should include the model, instructions, and any tools you want to include with your agent. So when we say tools, the Azure AI agent supports a couple of built-in tools. So there's file retrieval, code execution, Azure AI search, and I think there's like even data interaction with like Bing. So there's a lot of tools you can use that are already built in. And you can also include your custom plugins in your agent definition as well. Then once your definition is complete, you use that definition to create your agent. Then you invoke your agent on the thread, and it will start performing those instructions you specified in your definition. So, do we have any questions? And if not, someone asked if there's an alternative to Azure AI Foundry. In this case, for the Azure AI agent, I don't believe there is, but you can use the Semantic Kernel SDK with different types of projects and models and hubs, if that helps. Okay, so Graham, do you want to take over?
Yeah. Okay, so if we can flip to my screen, and I will start demonstrating what we're going to do next. So hopefully you are now looking at my screen, and you can see the Azure portal with the Azure Cloud Shell open and some code and so on there. So what we're going to do is just talk you through a very simple agent that's built using Azure AI Agent Service in Azure AI Foundry and Semantic Kernel as well. So the scenario is this. The scenario is, imagine that you are working for a large organization. You periodically need to submit expense claims. So during the month, you kind of gather all your expense data, and you maybe have that in a spreadsheet or a file or something. And you want an agent to go and take that data and do whatever needs to be done in order to claim that expense claim. So that's the scenario. Let's look at what we've got here. I can see that I'm in this this command shell. Let's just look and see what we've got kicking around in this folder. So I've got a few files. You can see I've got a .env file, which is my environment for my Python code, and that contains things like the project ID for my Azure AI Foundry project, and also things like the connections to the project, the name of the model that I want to use, all that type of thing. And all of that stuff, if I actually look here, I've got an Azure AI Foundry project already set up. The project is called SK Agent, and within that project, I have deployed a GPT-4o model. I could use, practically, well, not practically any model. There are a number of models that are supported by Azure AI Agent Service. GPT-4o is just one of them. There's a whole bunch of others that I could choose to use, but that's the one I'm using here. So I've got my project, I've got my model, and I've got my environment file here set up with the details for connecting to that and getting the model. What else do I have? I have this data.txt file, and you can imagine in reality this would be a spreadsheet, maybe in your OneDrive or in a SharePoint location, or maybe just even on your local computer. Just to kind of show you what's in there, we'll just take a look at the contents of that file. It's very simple. It's just basically got a bunch of dates, descriptions, and the amount that I was charged for that. So I've just been keeping a running total of expenses as the month has gone on, and that's what I'm going to use. Now, the real fun and games happens up here in the top pane, where I've got my code. So we'll just clear ourselves a little bit of working space here and take a look at that. So I've got this code file, and the first thing I'm going to do is I'm going to add some references to the namespaces that I'm going to need to work with in this code. So we'll just paste in my references. Obviously, I've got some general sort of Python stuff. I'm loading my environment variables. Then I've got a number of specific things I'm going to have to work with. From the Azure side of things, I'm going to use my Azure credentials to connect to the project. That's the basis of authentication I'm going to use. And in this instance, I'm going to use the default credential. In other words, the Azure account that I'm currently running this code as. In reality, we would probably use a managed identity for a service that's running somewhere, or something like that. But in this case, we're just going to log in using my Azure credentials. And then from Semantic Kernel, specifically the agents framework within there, I'm going to be working with an Azure AI agent. As Becky said, Semantic Kernel supports multiple different types of agents. We're going to focus on using an Azure AI agent from Semantic Kernel. And I'm going to need the settings that are required to connect to that. And I'm going to need to run that conversation on a thread. So I'm importing those namespaces. And Semantic Kernel all runs around this notion of a kernel. And within that kernel, there are going to be functions. Becky earlier on mentioned the idea of plugins. So we're going to use a plugin in this. So we need to import that kernel function space as well. And because there's a little bit of kind of dynamic, the agent itself needs to find the plugin that it's going to call, needs to find the function. We're going to give it some help by importing this typing library so that it can figure out the different data types of parameters for the function that we're going to use. So that's the references I'm going to use. The code basically that's already here just loads that data file that we just saw. It loads up that data file and then asks me to enter a prompt. Just like with any other large language model, I'm going to enter a prompt, and that prompt combined with the data is what we're going to send to the agent to get processing. So how are we going to do it? Well, the first thing is we're going to create this plugin that I mentioned earlier on. So let's go and add a plugin here. And I'm going to do that with this code here. So what's going on here? Basically, it's a class. I've created a class in my Python app. We are simulating email functionality. In reality, I would write the code that's going to connect to an SMTP server or some sort of service and actually send an email. In this case, we're just going to simulate that just to keep things simple by just printing out as if it were an email. So we'll get the subject, and the body of the email being printed out. And you can see that type annotation there in the parameters for my function. I've said that I've got this parameter called to, which is a string, and the sort of definition of that is this is who we're going to send the email to, the subject and the body. So basically just a function that I've created in Python. So that's my plugin that I'm going to use. Let's actually get the agent set up now. And the first thing I need to do is I need to get those configuration settings so that I can connect to my Azure AI Foundry project. So let's go and add that code in there as well. I'll just fix the indenting because it's Python and it cares about that kind of thing. So there we go. So we're loading my environment. And you'll notice that I'm using that Azure AI agent settings. That was one of the namespaces from Semantic Kernel that I imported. And it's pretty smart. It's pretty good at looking at the environment variables, looking at what's been loaded, and figuring out, based on the names of the parameters there, which ones it needs. So it knows how to find the connection string for my project. It knows how to find the name of the model that I want to use. It just grabs all of that and wraps it up in this Azure AI agent setting object that I can then use in my code to get those values when I need them. So everything's set up ready for me to connect to my project and work with an agent there. So let's go ahead and write the code to connect to that project. And I will just put that in there, connect to the Azure AI project. Again, we'll just do our little indentation thing. So what am I doing here? Well, first of all, I'm getting the default Azure credential, mentioned that earlier on. So the credential that I'm currently running this code as. I've added a couple of little exclusions in here just to save it trying to find, there could be multiple kind of sessions going on. So it's not going to look for those. It's just going to grab my default Azure credential. And then it's going to create a client. In other words, a proxy client object that effectively represents the connection to my Azure AI project. So I've got this connection that is going to connect using those credentials. And that's my project client, which I'm going to use to do the work I need to do within Azure AI Foundry and specifically within the Azure AI Agent Service. So now we need an agent. Let's go and write the code that's going to create the definition of my agent. So we are going to use this code here. We'll take a look at this code in detail. So we are creating an Azure AI agent. That's the point. So this is the definition for the Azure AI agent that we want to create. And it is going to use the model that is in my settings. So that model, that GPT-4o model that I deployed, it's going to grab the name of that from the settings. And that's the model that it's going to use to do its language processing. I've given it a name. I'm just going to call this thing expenses agent. And I've given it some instructions. In other words, a system prompt. So I'm telling the agent, this is how I expect you to behave. This is what you are going to do. You're an AI assistant for expenses claims. And when a user submits some data and requests an expense claim, you're going to use your plugin function to send an email. And if I scroll that way, you'll see to expenses@contoso.com with the subject expense claim and a body that contains the itemized expenses with a total. So I haven't actually, written the code to call the function myself. I haven't told it the name of the function or the parameters. I've given it a kind of natural language explanation of what I want it to do. I want you to use a function to send an email, and here's the details that I want you to use to send that email. And then I want you to confirm to the user that you have done that. So that's the behavior of the agent. That's what the agent actually is going to do. All right, to make that work in Semantic Kernel, I need to create a Semantic Kernel agent, which might sound a bit weird because we've just defined an agent, but we're working with two different frameworks here. So what actually happens is I have my definition for my Azure AI agent, and then running within Semantic Kernel, I effectively have a wrapper around that. So my Semantic Kernel agent will use the definition here. So you can see I've given it the definition of this Azure AI agent here. So you're going to create a semantic kernel object that represents the agent, and it's going to wrap around this agent here. This Azure AI agent using that definition. And crucially, I'm going to tell it about the plugins that's available for it to use. So in this case, we've just got one plugin. We're going to send an email. We could build a much more sophisticated agent that does all sorts of things, that can send an email, that can check expense policies, that can do various different things with different systems, just by adding as many plugins as we need. In this case, we've got one simple plugin that we've added. So I'm now all set up. I've got my agent. I've got my semantic kernel kind of wrapper around that agent. I've got the plugin prepared for it to use. So now we just need to have the code that gets the thing to actually do something. So let's put that in there. And I am going to put in this code here. You can see there's not a huge amount of code. One of the great things about using these agent frameworks is it really cuts down on the amount of code you need to write because it does a lot of the work for you. So what's going on? Well, as Becky said earlier, our agents run on a thread. So we're going to create a thread, and that thread is going to be connecting using my project client. So we're going to be running that AI Azure AI agent on that thread. And that thread is going to be how we manage the conversation. Think of a thread as just being the thread of the conversation. So that thread is going to have messages added to it, and the agent and the user will exchange those messages. And effectively, it's a conversation. So in this case, we are going to create some messages and add to that. And the messages, we're going to add basically just one message. We're going to add a message. So we've already defined the system instructions, that's up there. And we've already prompted the user to say, hey, here's the data that you've got in your file. What do you want me to do with it? So I'm going to answer that question when I run the program. And that answer that I get is going to go in here, prompt, and we're going to append the expenses data. So we're going to send to the agent whatever it is that I tell it I want it to do, and we're going to send it the expenses data so that it has that data to do something with. Then we're just going to get a response. We're just going to have the agent respond to that on that thread with those messages. And we'll print out whatever the response is that comes back from the agent. So it will do whatever it's going to do. It will look at its system instructions. It will figure out based on the data I've sent it and the prompt I've given it what it's supposed to do. If it thinks it's supposed to send an email, then it will go and send an email, and then it will respond to me. If something goes wrong, let's hope it doesn't, but if something goes wrong, we'll just print the error. Otherwise, when we're done, we're just going to delete the thread, and in fact delete the agent. So we're really just spinning up this agent in order to do this immediate piece of work. Now, in a real program, I would probably have a bit of a loop. I would keep track of the conversation history. I would have a kind of exchange of messages back and forth between me and the agent. In this case, it's a simple one and done. I'm going to send it an agent, and it's going to then do something with the message that I send it. So that's it. That's my code. That's everything we need. I'm just going to save that. And just in case I fat fingered something, I'm going to move this up and keep it open so that I can get to it if I need to. But in theory, we should now be ready to run that. So I've already authenticated with Azure. I've already signed in. So now I'm ready to run my code. And to do that, we're just going to say it's Python semantic kernel.py is the name of my script. So let's run that. And off it goes. It loads up the data. So that's the data that I've got. Typically you would attach that if you were actually building a proper application. You would attach that, or you would give it a link to that data in your OneDrive or whatever. What would I like to do with it? I'm just going to give it an instruction. I'm just going to say claim it. Go ahead and claim my expenses. So it's going to interpret that and figure out, well, what should I do based on my system instruction, based on the data you've given me, based on everything that I know, what should I actually do? And you can see it's actually printed out my expense claim. So it's run that function. It's figured out, oh, hey, this looks like you want me to do an expense claim. That means I need to send an email. I'll go find the function that lets me send an email and I'll call it. So it's done that, sent the email. And then it's responded to me. It's told me what it's done. It said the expense claim has been submitted successfully to expenses@contoso.com. So it's done exactly what I asked it to do and used that plugin to do it. So that's the demo. Hopefully that is useful for you. If we can switch back to the slides now, and we'll just close out from there.
Oh, well, that's fine. Someone asked where the settings were loaded from. Do you want to just mention how you loaded?
Sure, yeah. So they could be loaded from a number of places. You would either set them up as environment variables, just like you would do in any sort of either Linux or Windows environment, just set your environment variables. Or in the case of a Python program, there's a file called .env, which is just a text file, and it's just a configuration file. It contains the name of the setting and then the value. And when I used that load.env line of code in my application, that's where it loaded that data from. And then the semantic kernel is smart enough to look at all of those settings and based on the name of them, figure out the ones that are relevant for connecting to Azure AI Agent Services.
Thanks, Graham. Hopefully that helps. Someone else asked, why does the agent run on a thread? The thread helps to manage that conversation and the state of the agent and also the chat history. There's a lot behind the scenes that thread does for you so that you don't have to write so much code. And I saw one really great question. Someone asked, why do we need multiple agents when we can create multiple plugins? There is a multi-agent orchestration module that kind of demonstrates that effect. So in that module exercise, we have a what do we have? We have a reviewer agent and a writer agent. So each agent is responsible for its own tasks, and it helps you triage and isolate those tasks and maybe any errors or incidents, or maybe you can even fine tune that process a little bit better with those separate agents. We also have another project that is like a triage multi-agent kind of thing. And so you'll have one agent that's just responsible for performing DevOps operations like starting the server or restarting services or like reading and writing to log files. And you'll have the other agent that tells the DevOps agent what to do based on what errors happened in the log file. So it's just to isolate those different parts of your program so that one plugin isn't responsible for everything. Hopefully that helps answer some questions. So let's move on. My cursor disappeared, so I hope we can get through the rest of this demo. All right, let's do a knowledge check. I hope you guys are ready. So get ready in the chat to answer these questions. So we're going to ask, what is the main purpose of the Azure AI Agent class in Semantic Kernel? So we have option A, to provide a low-level interface for directly managing AI models. B, to simplify the use of Azure AI Agent Service by abstracting complex operations. Or C, to replace the need for prompt templates in AI workflows. I wish we could play the Jeopardy theme, but I'll give you guys a moment to think. Okay. Answers in. You guys ready? Let's see. The answer was B. Hopefully you answered B. And if not, we have another question. Don't worry. Which component in the agent framework manages conversation state and stores messages? Agent threads, agent chat, or AI service connectors? Okay. The answer will be revealed now. Agent threads.
Can't stand the tension.
The tension, right? All right. Final question. Which step is necessary to enable an Azure AI agent to use a plugin? A, modify the AI model's architecture to integrate the plugin. B, configure the plugin in Azure portal before using it in Semantic Kernel. Or C, define a class with methods annotated using the kernel function decorator. We talked about this, guys. We talked about this. And the answer is C. So if you answered all 3 questions correctly, congratulations. You are very cool and very smart. And Graham, do you want to take over the final slide?
Sure. Yeah, let's just summarize what we've done. So we've talked a little bit today about building agents with a combination of 2 frameworks, really. We use the Azure AI Agent Service, and you can use that, to build agents on its own. You don't need to use Semantic Kernel with that. We chose to use Semantic Kernel because sometimes you'll want to have maybe multiple different types of agents, or maybe you've already made that investment in using Semantic Kernel and you're used to using that. And it's a really comprehensive framework for building agents that sort of adds to the power of using the Azure AI Agent Service on its own. So being able to use Semantic Kernel to wrap around that allows us to do things like add those plugins and build that solution. So we saw how to combine those 2 frameworks together, define our agent, and then define plugins for that agent to use, and then ultimately to have a conversation with that agent on a thread where we pass messages to it, and it intelligently figures out when to use its plugin functions and when to do the various tasks it needs to do. I hope you found all of that interesting. I hope you are fired up and excited to go and explore a little bit further for yourself. Please go and take a look at the Microsoft Learn module. We'll be flashing up links at the end of the session. And study this in a little more depth for yourself and try out that lab for yourself. You too can build an agent that prints out an email. So you can go off and have a go at building out exactly the demo that you saw me build here and really dig into the code and experiment it with it for yourself. This was the Guinness World Record attempt stuff that I mentioned earlier on. The Guinness World Record, we've already done that. By all means, join in. But at this point, we've already got the record. But please take a look at the link and please take a look at the additional training and activities that are available. There's a whole bunch of exciting things that you can dive into to learn more about working with agents. And thank you for coming along today. Thank you for spending your morning / evening / afternoon, whatever time of day it is, with us, and for participating in this. It's a great community of people. I know there's a lot of people behind the scenes that work really hard to put these sessions on. So thank you to everybody who's helped us to do that. And please use these links. Take a look at Microsoft Learn. We have this credentialing and certification program as well. So if you want to really dive deeper, improve your skills, then please dive in and do that. And there are a whole bunch of other activities running, like I said, as part of Skills Fest between now and the end of May. So please participate in that. That, I think, takes us to the end of our session. So thank you very much. Hope you enjoyed it.
Oh. Got it. All right.
So thanks, everyone.